Hello students, welcome to Deeksha Karnataka again. Even though the picture says electromagnetic induction, in this session today we are going to discuss three chapters: magnetism and matter first, then we are going to discuss electromagnetic induction, and lastly we are going to discuss alternating current or AC as well. Entertainment sir, can I get full marks in boards PCM only by solving questions from Brahmastra and Chakravyuh series? Definitely, if you have watched all the videos of our Brahmastra and PU board series, definitely you can score full marks. No worries, if you see all the videos, all the lectures, and if you solve numericals that I have prescribed in our Brahmastra series, definitely you can score out of out, no problem. Okay, and we will also help you in future with one video where you can check all the concepts in one single lecture. Okay, that is also in the pipeline, we will do that. But if you want to make sure that 70 out of 70, then definitely if you have watched all our Brahmastra series videos and the numerical that we have done, and Chakravyuh, obviously Chakravyuh is for MCQs, so everything will be in place. But while discussing Chakravyuh series, I told you there are certain variations. If you have keep that in mind, then definitely you can score. Now today, as I said, it is not only electromagnetic induction. We will start with magnetism and matter first, then we will discuss electromagnetic induction, and then toxic, high toxic. This is south pole. Initially the magnet was like this, right? North pole, south pole. The length was 31.4 centimeter. Now once you have bent, what changed? What has changed? The length, the effective length of the magnet is now changed. What is the effective length? The effective length is this, right? So this is basically, if you consider this is to be a semicircle, if this is R, this is R, so the effective length is now 2R. So you have to calculate this radius of this new semicircular phase, then you can calculate. Good morning technical. Hi. So now let's solve this question. So how to solve this? First, we know that this is a semicircle, right? Semicircle, and the length is 31.4. So this will be 31.4, right? So if you go inside the circle, it will be 31.4, but effective length is now changed to the diameter of the circle. So what is the formula? This is a circumference, right? Circumference, we have to calculate the circumference, that is 2 pi r is usual circumference for the complete circle, but here we have only half circle, so it will be only pi r, and pi r will be equals to the length given in this question, 31.4. So r will be 31.4 divided by pi. Now what is the value of pi? Pi value we can approximately taken as 3.14. so if you cancel it, it will be 10 centimeter. So r is 10 centimeter, so 2r is 20 centimeter. 20 centimeter means what? 20 centimeter means 0.2 meters. Okay, so 0.2 meters we have calculated. Now what is the magnetic moment? Magnetic moment is basically given by the distance times strength of single magnet. Strength of the single magnetic monopole is given 0.5, so it is 0.2 into 0.5, so that will be 0.1 ampere meter square. Okay, so this will be the answer to this question. So option A is the correct answer. Vikas, so the question states that we have a long magnet of 31.4 centimeter, right? Now we have bent that magnet into a semicircular form, so that we have to calculate the magnetic moment right now. So magnetic moment is similar to that of dipole. Okay, so what is the if you remember, what is the dipole moment? Dipole moment was the strength of one single charge times the distance between them. Now in case of magnet, single charge is not there, we call it pole strength. Okay, pole strength is important, which is equivalent to the charge Now as you have bent them, the distance between the poles now changed. Okay, so this is the new distance. Initial distance when they are straight, the distance between them was 31.4 centimeter. Now because you have bent them, the distance between the poles now changed. So how to calculate this new distance? To calculate this new distance, we know that it is bent in a semicircular form. So semicircular form, what is the perimeter of a semicircular form or circumference of a semicircular form? So the circumference is basically pi r, right? 2 pi r is normally for a full circle, pi r is for semicircle. So pi r is equal to 31.4. that is the distance between them, right? If you make it straight, that will be the 31.4 centimeter. Now because you have bent them, the new radius is r. So from there you can calculate the r to be 10 centimeter, right? And this is 10 centimeter, this is 10 centimeter. So total distance is 2r, that is 20 centimeter. And 20 centimeter is obviously not SI unit. You have to convert it into SI unit, that is 0.2 meters. Now 0.2 meters we have converted. Now we will use the formula similar to that of dipole, that distance between the poles and the pole strength of one monopole. So pole strength into the distance is basically the magnetic moment, that is 0.1 ampere meter square, right? I hope this helps you. Chandan saying it will be option B. So 0.2 into 0.5. Okay, 0.2 into 0.5. What? Okay. If you have confusion, let me remove it. This is very common mistake you make. So 0.2 is basically 2 by 10. 0.5 is also 5 divided by 10, right? So now what you can do, you can cancel it. How? You can cancel 5 2s are 10, 2 1s are 1. So 1 divided by 10. 1 divided by 10, so this is 0.1. Because 5 into 2 is 10, that 10 is reducing one of the zeros. So you might think, okay, if it is 0.01, no, 0.01 is not the correct answer, because 5 into 2, that 10, that is reducing one of the zeros. Okay, that is why it is 0.1, not 0.1. 0.01. Okay. This is a very common mistake, not only you, many students make that. So be careful. Don't make that mistake, even though you are not allowed to use calculators. Okay, you have to be careful. If you are unsure, you can use this method to find the value. Sir, it is not 0.5 into 0.1. It is 0.5 into 0.2. It is 0.5 into 0.2 because we are finding 2r, right? Not r. So 0.2 into 0.5 will be 0.1, not 0.01. Right? I know, Chandan. So be careful. That is why I am saying in exam also you might be tempted to answer 0.01 because it is very, very common mistake students make, that what will be the multiplication. When I was at your age, maybe I would have also made this kind of mistakes, but these are very common. Don't worry about too much about it. Now next question, another easy question. Let's see how many of you can answer. A bar magnet of magnetic moment M is cut into 2 equal parts along with its length. Okay, the magnetic moment of the either part is, now we have a magnet, we have a north pole, we have a south pole. If we cut it from the middle, then what will be the magnetic moment for both parts, any one of the parts? So now we have cut it from the middle, so that means this is south, this is north, this is north, this is south. Easy question. I hope you can answer, but there is a variation of this question. If the same magnet is cut along its length, okay, along its width perhaps, so if it is cut like this, then what will happen? What will happen to the pole strength? Okay, this one I will not answer. This one you have to think and let me know later on in the main comment below that what do you think about this cutting. But this cutting is easy to answer. What will be the magnetic moment? Let's see if anyone answers. One A, Shagupta was correct. 1A, Shagupta was saying 2B. No, Shagupta. Once you cut this magnet into this like this, what will happen is the pole strength will remain same, right? Equal strength will appear in this side, but the distance is now changed. The distance is now changed, so distance is now d. Initial distance was say 2d. Okay, now the distance is only d. So initially m was 2d into m. Now the m dash, new m dash, each of them, not the total magnetic moment. Total magnetic moment has nothing to do with it, right? So now the new magnetic moment is d into m. D into m means it will be basically capital M by 2. Okay, so option will be C. Correct option will be C. Now this is a homework question for all of you that you can check and answer later on in the main comment below. I will be responsive for that. This is an interesting question. Now another easy question. A bar magnet of magnetic moment M is placed in a magnetic field of induction B. The torque exerted on it is m dot b minus m dot b, m cross b, b dot m. Yes, Shagupta, 2C was the answer. Now 3. Easy question. There is a hint that what they have asked you to find. Okay, it is asked to find about this quantity. Okay, so there are two ways to answer this. First of all, you can remember torque applied in case of electric dipole, the same formula for here as well. And another thing is torque, what type of quantity is torque. If you know that, you can answer it. 3C, Chandan 3C, Chandan R 3C, Shagupta 3C, yes. So torque is a vector quantity, so only one vector quantity is given, that is m cross b. In case they give you b cross m also, you have to remember that b cross m is basically not the torque, it is negative of the torque. Okay, it is m cross b. M should come first, b should come next. Okay, so in actual exam maybe they will give you b cross m as an option as well. Okay, so you have to be careful about that. Now next question. A bar magnet is held perpendicular to a uniform magnetic field. The couple acting on the magnet is to be halved by rotating it. Then the angle by which it should be rotated is. So a bar magnet is held perpendicular to a uniform magnetic field. So there is a uniform magnetic field here. Okay, a bar magnet is held perpendicular to it, say north, south. Okay, and what you have to do, the couple acting on the magnet is to be halved by rotating it. Then the angle by which it should be rotated. Now what is the couple? Couple is same as torque. We have seen the formula in the previous case. It is a Bm or Mb sine theta. Initial angle was 90 degree. So tau 1 is basically B into M sine 90. That is B into M, that is the initial torque. Torque and couple are same thing. Okay, so sometimes in mechanics we use the term couple, but more refined term is torque. So just to confuse you, they have changed the language, otherwise it is the same concept, right? Now you have to rotate it to make the torque half. So if you want to make the torque half, by what angle you should rotate it so that this theta gives you a half value. So basically what you have to do, you have to find the value where sine theta is basically half. Okay, so what is the value of theta? Then you have to, that is not the answer by the way. If you just find the theta for half, that is not the answer. We know that sine 30 is half, right? Sine 30 is half, so you have to rotate the angle by so theta is 30 degrees. Now what was the initial theta? This is final theta. Initial theta was 90 degrees. So how much angle you have to rotate? The angle you have to rotate, that is delta theta, that will be 90 minus 30, that is 60 degrees. Be careful. So even though the problem seems good, you have to be careful. You have to find the difference in the angle. So angle will be 60 degrees. 5C, Shagupta was saying 5C, yes, and Chandan was saying 5B. So Chandan 5A also answered, 5D also answered. So no, D is basically when you started. Okay, so this is a very common kind of tricks that you see in your KCET exam. Okay, so first they have given you angle. Based on that you calculate the theta, but if you leave your answer there, it will be wrong. You have, the question says by how much angle you have to rotate it. Okay. So you have to rotate it by 60 degrees. You have to rotate it to 30 degrees. So based on the question language, answer may be different. Okay, here they have said by how much angle you have to rotate it. So you have to rotate it by 60 degrees. Only Shagupta answered it correctly. Now let's see the next question. A bar magnet of magnetic moment 10 to the power of 4 joules per Tesla is free to rotate in an horizontal plane. The work done in rotating the magnet slowly from a direction parallel to the horizontal magnetic field of 4 into 10 to the power of 5 Tesla to a direction 60 degree from the field is. So now we have to find the work done. Okay, so magnetic moment is given. Okay, 10 to the power of 4 joules per Tesla. The magnetic field is given 4 into 10 to the power of 5 Tesla. Okay, now you have to rotate it by an angle of 60 degrees. Okay, initial angle was initially obviously it is aligned along with the external field. Now you have to rotate it to 60 degrees. What will be the work done? What is the formula for work done? So work done or energy formula was PE cos theta. Okay, P is given by 10 to the power of 4, not P, sorry, I always remember the electric one, not the magnetic one. In case of magnetic it will be MB, sorry, it will be M into B. So M is given 10 to the power of 4 joules per Tesla. Magnetic field is given 4 into 10 to the power of 5, and you are rotating it by an angle 60 degrees, so it will be cos 60. Now there is a negative sign, but we for most purposes we ignore the negative sign, right? I think okay, there is a mistake here, it will be minus here. Okay, magnetic field cannot be that strong, magnetic field will be minus. Okay, so it will be 4 into 10 to the power of minus 5, so it will be 0.4 into cos 60. Cos 60 is half. Okay, 0.4, why 0.4? 10 to the power of minus 5, 10 to the power of 4, so it will be 10 to the power of minus 1. 10 to the power of minus 1 means 0.4, and cos 60 is half, so it will be 0.2 joules. So you have to do 0.2 joules of work. Okay, 6A, Shagupta answered it correctly. Now next question. A magnet of magnetic moment capital M is rotated through 360 degrees. 360 degrees. There is another small printing error. 360 degrees in a magnetic field H. The work done will be mH, 2mH, 2 pi mH, 0. So you rotate it 360 degrees. So what is the work done? I will not tell you the answer, easy question. Chandan is saying 7A. Shagupta is saying 7A. So angle of rotation is 360 degrees. You have to, so first, what is the meaning of 360 degree? It is not 180 degree. Okay, 360 degree means you rotate it to 180 degrees, so north and south. It rotated to north and south, then again you rotate it back to north and south. This is 360 degrees. So what is the work done? So first you rotate it, you do some work. Secondly, the magnet rotates itself. So whatever work you have done, that work is done by, next time it is done by the magnet, because magnet always wants to align itself along with the external field. So no matter whatever you have done, the 360-degree rotation in mechanics also represents zero displacement. Okay, so zero displacement means work done cannot be mh, work done has to be zero. Okay, so work done has to be zero, because 360-degree rotation means from where you have started you have reached exactly at the same place, right? And the work done basically represents that if you have done some work into the system, is it having any energy stored into it or not? If it is not storing any energy, then you cannot say that work done is mh. If you have done some work, that work is again done by the magnet itself, so that they cancel each other. Total work done is zero. Okay, so total work done is zero. Okay, 7D will be the answer, right? Stanian answered correctly. Now next we have we will solve questions from electromagnetic induction. A magnet is brought near a coil in two ways: rapidly, number one; number two, slowly. The induced charge will be more in case of one, more in case of two, equal in both cases. It depends on the radius of the coil. Okay, now let's see who can answer it. Hello, anyone? Answer this, please. Vishwanath, you mention the question number, please, so that I can identify. Chandan is saying 8A, Vishwanath is saying A, Tanian is saying 8D. Okay, so you have to remember that the induced EMF is basically rate of change of flux linked with it, right? And more the induced EMF, more will be the charge, right? So and you see that if dt is small, epsilon will be higher. Epsilon will be higher in case dt is small, right? So in this case, as you can see, in rapidly means the dt is smaller for rapid case, right? If you do it faster, that means the time required for the flask to change is less. Same flask is changed, so d phi is same for both cases. D phi is same, whether you bring it rapidly or slowly, d phi will be same. But rapid case means dt will be smaller. So smaller dt means more induced EMF. More induced EMF means more induced charge. So it will be more in case 1. It is independent of the radius. Radius does not change it. Okay, even though there is a role of radius, but because radius is fixed in both cases, if you bring it rapidly, the charge induced will be more. So case 1 will be where you induce more charge. Now next question. An aeroplane is flying horizontally with a velocity of 360 km/h. The distance between the tips of the wings of the aeroplane is 25 meters. The vertical component of Earth's magnetic field is 4 into 10 to the power of 4, 10 to the power of -4. This is in power. Okay, Weber per meter square. The induced EMF is, so an aeroplane, we have solved a similar question in the past. So aeroplane is moving in this direction, so the vertical component is given. Even though the Earth's magnetic field is not there, but this kind of question can come because here they have given you whatever value is required. So this is vertical component, okay, of magnetic field. This is the speed. Okay, so they are already perpendicular. So whatever required to solve the question is given to you. So this kind of question still can come, okay, even though the horizontal and vertical components are not there. So Shagupta is saying 9A. Let me solve it. What is the formula to use? Formula to use is, by the time I am answering, if you know the option, you can mention. Chandan is also saying A, okay. Yes, last question 8A was correct. Shagupta, Vishwanath. Now, so let's see. It is B, V, L. Okay. So if they are perpendicular to each other, it is B, V, L. Right. Now what we have to do? We have to calculate. B is already given. 4 into 10 to the power of 4 minus 4. Sorry. Velocity is given. 360 kilometer per hour. So you have to convert it into meter per second. So 360 kilometer per hour means 5 by 18. This is the factor you have to remember to convert easily into meter per second. Okay. Otherwise you have to multiply with the 1000 in the numerator, then divide by 3600 in the denominator. So whatever you do, you will get this factor. So this is the factor that you have to remember. This is a shortcut way to solve. So 36 to the 18, so it will be 20. So 100 meter per second is the speed, right? I hope you know this factor, how to convert kilometer per hour to meter per second directly. If you don't know, you have to remember it. 5 by 18 for kilometer per hour to meter per second. You don't need to convert it into meter per second to kilometer per hour. Never comes like that. But so 5 by 18 the factor you have to remember. So velocity is 100 and length is given 25 meters. 25 meters. So 25 into 4 is 100. 100 into another 100 into 10 to the power of minus 4. So 10 to the 100 into 100 is 10 to the power of 4 into 10 to the power of minus 4. That is 1 volt is the answer. So 1 volt is the answer for this question. Okay. Shagupta was correct. Chandan was correct. Vishwanath, no, Vishwanath, you have to improve. You have to see that there is a 10 to the power of minus 4 here. So only multiplying this, converting velocity to velocity will not do. You have to apply BVL to solve it, right? Now, next question. Another interesting question. A conducting circular loop is placed in a uniform magnetic field of induction B Tesla. Okay. With its plane normal to the field. Now the radius of the loop starts shrinking at the rate of dr by dt. Then the induced EMF at the instant when the radius r is. So you have a loop like this and it is shrinking with time. So after some time it is shrinking. So size is getting reduced each passing second. Okay, and the rate of change is given by dr by dt. Okay, so at some time, okay, after some time, the radius is now r. Now you have to find the induced EMF at this time. So how to do that? So first of all, you have to understand what is the induced EMF. Induced EMF is basically d phi by dt. Right? Now what is phi? Phi is basically area into the magnetic field. Right? So what is area? Area is they are perpendicular. Basically here they have given BA cos theta is there, but because they are perpendicular, so cos theta we will not consider. Cos theta is 1. Oh sorry, now they are parallel. So basically cos theta will be 1, cos theta, cos 0 will be 1 in this case, so we do not need to consider it. Now so B into A, what is area of a circle? Area of a circle is given by pi r square and magnetic field is given by B. Okay, so we have to simply differentiate this quantity. So with respect to time. So with respect to time means now B is constant, pi is constant. So B and pi and B are coming out of the differentiation. So ddt of r square. So ddx of y square. You remember ddx of y square. How do we write it? We write first, we do the differentiation of y, that is 2y, and then we write dy by dx. Right? Same thing we will do it here as well. So r square differentiation is 2r. So 2r pi b, and then we will have a dr by dt as a byproduct. So what we have got? We have got 2 pi r b into dr by dt. So option B is correct answer. Yes. Saurav, we are currently doing electromagnetic induction chapter. We have already completed magnetism and matter at the beginning of the session. Currently we are going through EMI chapter. Once EMI is done, we will also have some questions from AC as well. Okay, so all these 3 chapters we will be covering in our session today. Okay, I hope this is clear. Current question is based on EMI. Okay, so simple question. I hope you understand it. If you have not understand, you can ask me once more. So basically what you have to do, you have to write the phi is basically b into a. Now area is pi r square for a circle. Now induced EMF is d phi by dt. So just differentiate it. B is constant, pi is constant, so pi b coming out. So dr square by dt. Now dr square by dt is same as dx, y square by dx. So what we have to do, pi b into 2r into dr dt. Okay, this is how we do the differentiation, right? So r is only changing, but magnetic field and pi are constant. So 2 pi rb dr by dt. This is the answer. So correct answer is option B. Right? Navya, welcome. Shagupta already answered. Chandan, Shagupta already answered. Okay. Saurav. Now next question. A copper rod of length L is rotated about one end perpendicular to the uniform magnetic field B with constant angular velocity omega. The induced EMF between its two ends is. So here copper rod of length L is rotated with an angular speed omega. Okay, you have to calculate what is the induced EMF at both the ends. Okay, so there is no linear velocity but angular velocity is given. So how can we solve it? And it is rotated from one end. Okay, so one end is fixed, another end is rotating. Now how to calculate the induced EMF? Interesting question. Chandan already answered 11C. Shagupta is saying 11A. So I don't know the answer. I have only solved up to question 10. Before coming to the class, I didn't get the chance to solve other questions. So I will solve it along with you. So how to do that? First of all, we know that the induced EMF is basically BVL, right? We know that. Now, what else we know is that it is rotating in a circular path, right? So circular path means there is a linear velocity associated with it. What is the linear velocity in case of circular motion? V equals to L omega. V equals to L omega. So we only have to put this L omega in this equation. So B into L into omega into L. That's it. Okay, just convert the velocity into linear velocity, put the value, you will get the answer. B omega L square is the answer. So B omega L square, definitely option A is the correct answer. Okay, Shagufta answered correctly. Viresh and Chandan unfortunately answered it wrong. Okay, so it will be B omega L square. Only thing, you have to convert this velocity from linear velocity to angular velocity. Just this conversion is required. Now this distance is L, so this distance L means this is equivalent to radius, right? V is equal to R omega. So R, instead of R you have to put L here, and the formula is straightforward, BVL. Put it, calculate. Okay. Next question 12. A coil having number of turns capital N and area A is rotated in an uniform magnetic field B with angular velocity omega about its diameter. The maximum EMF induced in it is given by. Now we have a different question. Similar but slightly different. We have a coil. Number of turns, how many? Number of turns is N. Okay, and it is rotated along its diameter. Now what will be the induced EMF in this case? Okay, So first of all we have to calculate what is the flask linked with it. Okay, flask linked with this is given by, this is a different question, even though it is similar to that previous one, this is slightly different. The flask linked with this given by number of turns into area into magnetic field B. NAB is the flask linked with it, right? And now we have to calculate what is the rate of change of rotation. Okay, so rotation is basically given by omega. So the induced EMF is basically, when you are calculating d phi by dt, okay, there will be you can say NAB is the flask linked and the time rate of change is basically omega. So it will be NAB omega. So that will be option A is the correct answer, not any other way around. Yes, Khan already answered, Shagupta answered, Chandan answered. Sir, for how long the session will go? It will be over in another, we have 12 questions, 8 more questions are there. As soon as you answer them, as soon as I can complete them, that will be over, right? Now we have next 8 questions is from AC. So if you are joining right now, and if you have if you are weak at AC is very important chapter in KCET. 4 questions, up to 4 questions can be expected from this chapter. It is coming out of one of the high weighted chapter. Okay, EMI and magnetism and matter, 3 questions average comes from those chapters. This is a very high weighted chapter. Here 4 questions come every year, so don't miss out on this question. So this is a very interesting question. As I can see, an AC generator produced an output voltage E equals to 170 sine 377 T volts, where T is in seconds, the frequency of AC voltage approximately. So they have given you some value. From there they have asked you to find the frequency. Completely different, right? So how to do that? What is the standard equation of output voltage? Standard equation of output voltage we generally see is Vm sine omega t, right? That is the standard voltage. Here instead of V they have given E, that is fine. I think they tried to give it epsilon, but because of font changed, it is now coming at as E. So V is equal to Vm sine omega t is the standard formula. So from there we can see that the maximum value is 170, and we can also say that omega is basically 377. Even though this looks like odd number, it is actually not. You will get a good value for that. Now what is omega? Omega, what is the relationship between omega and frequency? Frequency is basically 2 pi f, right? That is 377. So f is basically 377 divided by 2 pi. Okay, so f is basically equals to 377 divided by 2 pi means 6.28. Okay, 6.28. So if you cancel, if you see that this number 6 and 377, the nearest cancelable number is 360. If this number was 360, this number was 6, then you would have got 60 Hertz. In fact, this 0.28 number and this extra 17 number is actually compensating for that 0.28 number, and if you calculate it, you will get 60 Hertz. So how to solve this kind of questions without using calculator? You have to, because there is a 0.28 in the denominator, you have to reduce the top, reduce the bottom, so that you get a complete number, and according to the given answer, only other candidate for this is 50 Hertz. These are all very high numbers, so only other candidate is 50 Hertz. But as you can see that 60 is more close to this number than 50, so 60 will be the answer. Okay, this is how you can solve even though you are not using calculators. Okay, now question number 14. The voltage of domestic AC is 220 volt. What does this represent? Mean voltage, peak voltage, root mean voltage, root mean square voltage. Anjali, which question you are answering? Please mention the question number. That will be helpful for me, right? So all of you have answered correctly. 12A, 13C. 13C was correct. Yes. Chandan is saying 14D. Yes. So the answer is, as we know that if we say that 220 volt value, 220 volt means basically it represents the RMS value. Okay, it is not the peak value. So only candidate is peak value or RMS value. Okay, this is just something that is not have any meaning. Root mean voltage. So root mean square voltage is the correct term. Okay, not root mean voltage. So don't fall for the trap. It is basically RMS value or RMS voltage. RMS stands for root mean square voltage. Okay, you have learned about it in your PU1 kinetic theory, right? Yes, Navya, Shagupta, all of you are right. Chandan. Now let's see the next question. Easy question, I don't want to waste too much time. The peak value of alternating EMF E equals to E naught sine omega t is 10 volt and its frequency is 50 hertz. At a time t equals to 1 by 6000, the instantaneous value of the EMF is. Very interesting question. So time is given 1 by 6,000. Okay, E naught's value is given 10 volt. Okay, frequency is given 50 hertz. So how to calculate that? So first of all, we have to find omega. Omega is basically 2 pi f, right? F is given 50 hertz, so it will be 100 pi. 100 pi will be the frequency, right? Sorry, angular frequency. Now we have to calculate E is equal to E naught. E naught's value is given 10 sine omega. Omega's value is 100 pi and T value is given 1 by 6000, right? So cancels. I think there was one mistake here. Okay, but because pi by 60, it will be pi by 6, not pi by 60. Okay, I think it will be pi by 6. It should be 1 by 600, not 6000. Okay. So it will be pi by 6. So 10 sine pi by 6. What is pi by 6? Pi by 6 is 30 degrees, right? So sine 30. So sine 30 means half. That means 5 volt is the answer. So answer is option C. Yes. So 5 volt is the answer. Chandan, it will be sine pi by 6. Sine pi by 6 is sine 30. Sine 30 is half, right? Navya, how you are saying it is option B? It will be option C. Sine pi by 6, not pi by 3, not pi by 4. Okay. Pi by 3 is 1 by root 3, not even root 3. Yes. It will be option C. Okay, not option B. Next question. The RMS value of an AC of 50 Hertz is 10 ampere. The time taken by the alternating current in reaching from 0 to maximum value and the peak value of the current will be. So, RMS value is given 10 ampere. RMS value is given 10 ampere. The time taken by the alternating current in reaching from 0 to maximum value and the peak value of the current will be. So RMS value is given and they have asked you what is the time taken for it to reach 0 to maximum value. So 0 to maximum value, what is the time taken by it? This time, basically this time you are trying to find, and what else? You have to find the peak value. So peak value is easy to find. So RMS value is basically IRMS is maximum peak value divided by root 2. right? So maximum value, it should be small m, small I, sorry, small I. So small I m is basically root 2 into IRMS. Now root 2 is 1.41, right? 414 into IRMS is given 10, so it will be 14.14. So 14.14 ampere. Now what is the time? So to calculate time, first of all you have to find the time period. Time period is what? Time period is 1 by frequency. Okay, so 50 Hertz is frequency, so time period will be 1 by 50 seconds. That is the time period. Now from reaching from 0 to maximum value is time by 4, because you can divide it into 4 parts, right? 1/2, 1, 2, 3, 4, and they all take equal amount of time. Time period is basically this much time, right? So this is the total time period for one single wave. Now to reach from 0 to maximum is basically 1/4 of the time period. So the time taken will be T by 4, that is 1 by 4 5s are 200, right? So it will be, if you multiply 5 in both sides, you will get 5 by 1000. 5 by 1000 means 5 into 10 to the power of -3 seconds. Okay, so the answer will be option D. Okay, answer will be option D. 5 into 10 to the power of -3 seconds and 14.14 ampere. Chandan, no, Chandan. Not 16A. Anjali 15C was correct. Now we are not 16A, it will be, so if you just see that this is matching, you have forgot to check about this. This is 1 by 200, 1 by 200 means 5 by 1000. 5 by 1000 means 5 into 10 to the power of -3. Okay, so always try to make the denominator as a multiplier of 1000, 10,000, 100, like that. That will give you a 10 to the power of minus value in the top. Okay, so in this case of 200, if you multiply 5 in both top and bottom, so you will get 5 into 10 to the power of -3. Okay, so 16D is the correct answer. Now 17, the frequency of an alternating voltage is 50 cycles per second, that is 50 Hertz in the other words. Its amplitude is 120 volt. The RMS value of the voltage is, okay, frequency is nothing to do with this. We can simply calculate the RMS value. RMS value is basically 120 divided by √2, that is 60 √2. Okay, 60 √2 is the answer, but you have to calculate it. So 60 into 1.4. Okay, I will just do for first decimals. 60 plus 24, it will be around 84. It will be 84 volt, that is 84.8 volt. Easy question, but as it is difficult with the division. Okay, 120 by √2 division, if you are comfortable with, you can do that, but I am not comfortable with division with this irrational number. I am good with multiplication, so that's why I have converted it into 60 √2. Just did the rationalization, you know that, right? If you multiply both side √2 and √2, you can simply get 2 into √2, so these two will cancel with 60 √2. So this is what I have done, and then I have done the multiplication. For me, multiplication is easier to remember, right? So that's how you can do it also. So these are the small tricks, small tips that from my side. Not always you might stuck it here 120 by 1.4. okay, what will be the cancellation, how to do the cancellation, but you can simply make it 60 √2, which will be much easier for you to multiply. How did I multiply it? First of all, I multiplied 1 into 60, that is 60 obviously. Now 0.4 into 60, just multiply 4 and 6. 0.4 into 60 means 0.4 into 60 means 4 into 6, right? That is 24. Just add them. that is 84. This is how you can easily calculate faster. This is the faster way to calculate. Okay, calculation is very, very important if you want to crack KCET. That you have to remember. Okay, calculations, there will be a lot of calculation based questions. There is no other way. Yes, not all the questions are calculation based, but there will be some questions which are calculation based. You have to crack those questions. They are generally easier. Okay, the maximum value of AC voltage in a current is 707 volt. Its RMS value is approximately. So maximum value of AC is again same 707. Now in this case I have no other option. I have to divide it by root 2. Okay, so how can I do that? 707 divided by 1.4. Okay, I can cancel it with 7 because this is cancelable. So if I cancel it with 7, 7 2s are not 7, 7 let me write 14 and 0 here. Okay, that will be easier. I have removed the decimals from the denominator and put a 0 here. 7 2s are 14, 7 1s are 7, 0, 7 1s are 7, 0. Okay, so it will be cancelled. It will be 505 volt. The nearest answer obviously 500 volts. Okay, I think they have, by mistake they have given A and C same option. A and D will be different. Okay, so anyway, easy calculation. This calculation is easier, right? 18C. We have 2 more questions to go. Voltage and current in an AC circuit are given by V is equal to sine 100 pi t minus pi by 6 and I equals to 4 sine 100 pi t plus pi by 6. Now which one is leading? Voltage leads the current by 30 degrees, current leads the voltage by 30 degrees, current leads the voltage by 60 degrees, voltage leads the current by 60 degrees. Okay, so how can you solve it? There are one easy way, one slightly understandable but slightly longer way, that is by drawing phasor. Okay, so this is the time axis. Okay, first we have to understand that when both of them are sine or not, both of them are sine. Okay, this thing checked. Okay, this magnitude is not required. So first of all we have to see when both of them has same omega or not, same omega, that also checked. So minus pi by 6, what is the meaning of minus pi by 6? Minus pi by 6 means it is on the 4th quadrant. Okay, this is on the voltage is on the 4th quadrant. Now what is the meaning of plus pi by 6? Plus pi by 6 means it is in the 1st quadrant. Okay, so this is current. Now who is leading here? Obviously current is ahead of voltage, so current is leading, and by how much it is leading? Pi by 6, that is 30 degrees here, another is 30 degrees here. So current leads the voltage by 60 degrees. Okay, current leads the voltage by 60 degrees. Okay, this is the easiest way to understand. Otherwise you can do what you can do, you can take whoever is plus, that he is leading, whoever is minus, he is lagging. Okay, that much you have to understand. Then pi by 6 minus pi by 6, that is plus pi by 3, that is 60 degrees. That is another way to do it. Okay, but in my opinion, if you remember the phasor method, it is easier to understand. Negative means 4th quadrant, positive means 1st quadrant. Okay, and in case they have given you both values positive, then how you will draw it? You have to think about the angles in that case. Okay, so easy question, but slight knowledge is required. I see 19B Chandan only answered, but Chandan, it is not 30 degrees, it will be 60 degrees. Okay, Chandan, 18C was correct. Now next question, let's see, last question of the day. A coil and a bulb are connected in series with a 12 volt direct current source. A soft iron core is now inserted to the coil. Then the intensity of the bulb remains the same. The intensity of the bulb decreases, the intensity of the bulb increases. Nothing can be said. So we have a coil and a bulb. Basically coil means an inductor. Okay, and with this 12 volt direct current source. Okay, we have a direct current source. It is partly AC, partly EMI. Okay, we have a bulb over here. Okay, we have a bulb over here, we have inductor. Now this is connected to a 12 volt source. So initially, after some time, what is the role of inductor in DC circuit? It initially resists, then it becomes simple conductor. So as soon as it is a conductor, the bulb is glowing with a constant flow. Now if you insert a soft iron core, what will happen to this? Its inductance. As soon as you increase this soft iron core, its inductance will increase. So inductance basically depends on the medium which is there in the core, right? There is a proportionality sign, it is proportional to the mu. Right, so you are increasing the mu, that means the inductance will increase. Inductance increase means the bulb will, it will start resisting the flow of current. So immediately after you inserted the intensity of the bulb decreases because it is starting to oppose the flow of current. So immediately after, the intensity of the bulb will decrease. After a long time, after certain amount of time, okay, the intensity will be restored. But initially, as soon as you insert the iron core, its inductance increase. Inductance increase means the intensity of the bulb will decrease. Okay, so I hope you enjoyed today's session. If you have any other questions, Chandan was correct. No, Chandan was not correct. Chandan answered 19B. 20 I didn't see any answer. Okay, so if you have any questions, you can mention that in the comment below. And if you have not yet subscribed to our channel yet, don't forget to subscribe and join our WhatsApp channel. All the informations, all something new is coming, that will be posted in our WhatsApp channel. So I will see you in the evening with another live session of Chakravyuh. Till then, bye.